Hello, Peter. Nice to meet you. Aurélien and the other guys are coming. Hello, everyone. Up. Aurélien is here. Tac.
Hello.
How are you doing, Aurélien?
Hi, hello.
Aurélien, I will
Hey,
give you
everybody.
the status of animator, so you can do whatever you want. Okay. You
Okay.
can you can present and so on, share your screen. Okay.
I can kick you.
Exactly. You can kick me out. Welcome, everyone. I'm just waiting a bit before giving you the status because I need to accept everyone just to be sure. Up. We're 9. It's a pleasure to have all of you here. It's like a first try just to see how everything is going and so on. So if we see that you like it or if you have feedback for us to change the format, we'll be happy afterwards. So basically to make it better. I think, okay, we can start in 3 minutes. Almost everyone is there. Well, I hope everyone is okay wherever you are. In Paris, it's quite it's quite heat wave, I would say. So we're like really hot there. Ah, okay, nice to read. Yeah, that we're not the only one of dying of form here. Maybe Aurélien, just few words. I mean, you'll have like to speak about it again, but a few words maybe if you want to say what you are going to speak about, even if we shared it before, kind of the program, to explain to everyone what's the goal, what you wanted to share, what you wanted to speak about, what you wanted to show.
Also, you can introduce yourself to everyone. Maybe not everybody knows you.
Yeah, but maybe can we wait like 5 p.m. so that I don't repeat myself.
Okay, let's do that. Let's do that.
In the meantime, Kesha, can you sing a song or something?
Yeah, I can.
Yeah, thank you.
Okay, I don't know that many songs. Maybe I can sing the French national anthem to please you all and give you like this French feeling from Massa. Oh, we're actually quite a lot. We'll be already almost 20. Very nice. I didn't think that many like of you were interested at the beginning because not everyone answered. I'm sorry, I was spamming all of you guys. I was a bit stressed, you know, like to involve all of you. But no worries, in the future, going to spam you less. So yes. Sorry for the notifications in the builders channel. You know how it is. Discord is evil. More
Bonjour.
tech. Bonjour. Up. Hey, happy to have you to have everyone here. I think Aurélien, yeah, it's 5. So I mean, I will continue to accept people. I'm going to give you still the access. So you will have time, no worries, to ask questions and so on, live or by text if you prefer. Just maybe while Aurélien is speaking, the best might be for the beginning to let him present the things, and then like we will do like question times. So let's do like that. Tech. So Aurélien started. Tech.
Yes.
1 second. Well, you can start to you can start to introduce yourself maybe and what you are going to speak about.
Okay, so hello everybody. I'm Aurélien. I'm a developer core at Massa Labs, and I'm working on the node that you run each month to get your points, but also the nodes that make run the blockchain. And so today I will present you how to, so I assume that everyone is here as a builder on Discord. So you are quite familiar with technical, and this call will be to help you to set up your technical environment and to show you some example on how to develop with Massa. And so on the first part, I will show you how to set up a node in local and even more a full network in local. And in second time, I will show you an example of smart contract and how to deploy it and run it with a web interface. I will not cover Web3 on this call, maybe on another one because it will be too much. And yeah, that's basically the summary of the call. And I can start.
Yeah, can you share your screen already, or do I need to give you the animator status? Just let me know. If you can share, it's perfect.
If give me the permissions, I can't.
Okay, I give you, I make you the master of the discussion.
Thank you.
Let's go for it. Up. There might be people actually who are still coming, so that you might have to approve. I'm sorry for that.
Yeah. And also I will make some breaks sometimes to answer question if you have. So, okay. So yeah, how I turn this off, how it works. Okay, so I hope to see my screen. I don't have the chat.
Yes,
so
yes, I see the screen.
I count on you, Keisha, to give me problems if there is problems. Okay, yes. So I will start by presenting you how to run a local machine on your local node, on your machine. So there is a documentation already on the read the docs. Maybe I have to close my personals. Okay, so yeah, there is documentation that tell you how to do, and we will basically follow it for the start. And after you will, we will go a bit deeper with how to run two nodes together and how to run a full network with Docker and a new repository that we just published today. So yeah, I need to how I remove this sheet. Hide. Okay, so yeah, I have a few terminals. I have cloned the Massa project on the first one. Here we are in Massa node. I hope you see where I am. I hope you see it's enough big. I don't know, maybe I have to make it bigger. Tell me.
Yes, can you zoom just a little bit on both screens?
I will make it bigger. Right, that it should be better, right?
Yes.
Okay, so I'm in Massa node, as you can see, and the first thing that the documentation tell me is to build with the features sandbox. So in Rust, you can build with some features. We added one on Massa, which is sandbox, which allow you to build the node to run by himself and not to connect to the whole testnet. So I will run the command. It will take a bit of time to build because it's Rust, and it always takes a bit of time to build. But we can just check the other things to do. So we will have to create a key pair for our node, and so we will set up our private key to be the key that stacks, so that our node will stack on our proper network, and the addresses to have a minimal balance to play with it. So I will open a second terminal. I hope it will be zoomed also. No, because okay, it's command push like this. Okay. So I have already preloaded the client before, so that it don't take much time. So the client, when I type the command wallet info, as you maybe know, I hope you know, is give you the information about your keys that you have on your wallet. So for now, I have created one key pair. So we will use this one to set up our node. So here we have the private key, the public key, and the address. So the first things to do is to set up the private key of the node. So to be our. Okay, it's not compiled yet, no problem. So I will go to my Massa node folder and I will set up it to be fast, don't worry. We have the path here. We can check that they work well. And so we have to copy paste the key. That's why I made 2 terminals at the start. But I totally messed up my organization. Okay. So this one. Yeah. My bad. Okay. I had a previous file. Okay, so now I have set up my private key for my node. I will also set up the stacking key. So in the file that is the where we store the stacking key, everything is in the docs, but it's the same file as you set up in the testnet if you need, but I don't remember if you need. I will set up my address to have initial ledger, as I just said before. So I can modify also this. Maybe I have already did it so that it's much faster on the call. So yeah, the address you can see there, which is my address, is already in the initial ledger right there. So I have like 80 million tokens. I think it will be enough. And also in the smart contract ledger, I have set up my own address. And also the most important, at least, is to have one address here in the initial roles so that there is a node stacking, and I have left only mine so that my node creates all blocks of the networks, and I have more information in my debugs and it's more useful to follow. So we can see that the node just compiled. Nice. So we can run it. And when we run it, we will see that we are in sandbox version. And we will see that the genesis of the network. So what is the genesis is like when the network creates. So the network will create in 9 seconds. So we are in our proper network that will create in 9 seconds. And when we will stop the node and relaunch it again, it will create a new network. So each time you launch your sandbox node, it create a new network. So as you can see, I start stacking, create blocks. And so I can see on my clients, I will check like my balance, as you may all know. We can see it with wallet info. You can also see your roles. And I can see that I have my 80 millions. I have roles, and I start to have more balance because I'm creating blocks. So I have rewards. And with that, I have now a full node running in local. We will see how we can use it to test our smart contract just after. But yeah, that's basically the steps to create our local node. And then we can, for example, send a smart contract. We'll do it just after. But that's it for this part.
It was just to remind, just some people didn't understand. So here it's not to run a node just on Massa. It's to run your node locally, to have your own network, to basically be able, even when we are not in testnet, to be able to build your own smart contracts and dApps by yourself.
Exactly.
Test them. Exactly. That's it.
And also you don't have the limitation of the testnet. Maybe if the testnet is overloaded because we put a lot of transaction or something like that, you are on your own environment, and so you control everything. So yeah, the docs is on the readthedocs.io. You can check like the local network generation, and like as you see, it's not that hard. There is just some files to edit to have your initial balance. And with that, we have a nice first setup for developing. Now, if you want to have like a bigger network, you can use a repository that we create with Massa, which is, let me take it, yeah, which is the Massa Network Simulator. So what is this repository for? It can simulate a whole networks with Docker, and will start multiple Docker containers with one node on each, and you will be able to call them all, or to request to send operation to some as you want. You can make whatever you want. I will show you, but it's like one node on the local, but instead of one node on local, it's like a whole network in local. So I will share you the repository also after the presentation. Don't worry.
We have already a first question, so it's just because usually I would have wait for forwarding you the questions, but it's like, can this network be already kind of, you know, like public, or is it only like possible to make it run on one machine? I mean, can you connect like different machines together on it, or not? Like,
yes.
can you yeah, if you can read the question, yeah, I mean, it will be more clear than my.
Chat. Okay, see it. Can we share the testnet box? So it's okay. No, yes. So yes, you can. You can, if you run your nodes. I will show you right now because I have prepared this question. You can run your node on your address, like on your local machine. And if you expose your address and your ports, then you can connect another node to this one and make it bootstrap from. So for example, I have created another config.toml. It's like the config file that you can edit if you want to change your bootstrap list, etc. And so if you change your bootstrap list and then put here the right the right address and the right node ID, it will work. But you need to just do one thing. To be able to connect to the same network, you need to have the same Genesis timestamp. So what is the Genesis timestamp? Sorry. The Genesis timestamp is the timestamp when the network starts. So for example, if I launch my node right now, the Genesis timestamp will be in 10 seconds because the Genesis is in 10 seconds. And we have made an environment variable so that you can edit this this parameter. So I will show you right now. For example, if I want to take the timestamp that we are right now, it will become clear when I will show you. So I can set up my node like that and say that I want to have the Genesis timestamp in 1 minute, for example. So I can make it like that. And so, like, as you can see now, the node run in 24 seconds. Sorry. So now, if you have the same Genesis timestamp on the other node that you will run, for example, on the second node that I run on my second terminal, I also give another config file so that it will bootstrap on the first node that I set up on the left. So the node on the right will bootstrap on the node on the left, so that we can imagine that the node on the left is on one machine and the node on the right is on another machine. And so you can make the two connects if you edit your bootstrap list with the right data. So for example, on my case, it's like my localhost and the node ID is this one. So I will just check if the node ID is still the same on the config. And if it's the same, I will be able to connect. Just please. No, it's not the good one. So yeah, I will change it right there. I have put only one node so that it always bootstrap to my node. And if I didn't tell you lies, if I launch like this, you see it bootstrapped from my node in local. So you can see start bootstrapping is the log that you see when you are running a node on testnet, and the bootstrap successfully works. It's easy because there is no much data. There is only blocks. We don't have operation on this network, and you can see the two nodes are running well and in the same networks. So you can imagine that these two nodes are on different machine. I hope you understand it. Awesome. So yeah, I hope I think you understand it and it answers your question. Okay, so I will kill them. And so I will go back to like the doc. So yeah, you can do it with a lot of machine and create your own little network, but we make the thing easier with the Docker project because I can like open 10 terminals and make run 10 nodes with the same system, but it's a mess to do manually. That's why we created this repository. So yeah, I will show you. Okay, so I remove the chat. So the repository is simple. There is like a README on it. You can read it after the call, but I will explain you the most important parts. So the repository works with a config file, which is a JSON that you can see there. And as you see, we specify like the IP we will have in the network, in our Docker network, like the private key of the node, the public key, the static key, the address, the initial value that we put in the initial file just before, and the ports for the API. And also we can say if we want this node to run at the start before the Genesis timestamp, or to bootstrap from another one and then to start after the Genesis timestamp. And so you can build your own network with fully parameterized value. I don't know if there is much. It's very useful for smart contracts. It's not useful for smart contract. You can develop your own smart contract on one node, but maybe it's useful for some case that you want if you want to test multiple nodes, like the charge. If you want to spread your operation to different nodes, it can be useful. But this part is more like deeper. If you just want to code smart contract, you can run your sandbox node as I just saw before, just to be as I just explained before, so that we are clear. And if it's not your case and it's a bit complicated for you, don't worry, it's not useful for this. So yeah, so as I just saw before, as I just explained before, so you have all the values, and this value will be filled in the file of config so that you have nothing to do. And also on the main, you can like change if you want the network usage of your node so that you can simulate a node that don't have much connection, that have a bad connection, and that's it. So yeah, the most important is that you can modify the JSON. You can add more nodes if you want. You can delete some. And there is also the Docker file which build each node. So there is two possibilities in the Docker file. Either it get the repository from Git, and so it build it when it build the image, or it can get the repository from your computer if you uncomment this line and comment the Git once. So yeah, I will just show you an example. So I can run like the main, just simply run the Python main. And as you see, it started one node. Why it started only one node, but there is multiple configs here? Because the other one are not set up to be at the start. They should start 1 minute after, 1 minute and 2 seconds, and 1 minute and 1 second. So we will see if it works. Just as if you are familiar with Docker, I will enter some Docker commands on the right. Maybe it's not that big, but sorry for that. So here you can see that there is one node running, and that's the port for the API. It's mapped to 32. So we will wait like for some seconds, and we will see if the other node starts and they are well connected. To check if everything is well connected, we have set up like a little Python script also that made the request to the API of the nodes. So we can check multiple ports here. For example, I will explain. For example, the first node is linked to the port 32. So if I made request to my port in local 32, sorry, it will request this node. But if I made like a request to the port 41, it will request this node. And so you can choose which node you want to request with your API. So as you can see, all the nodes have been created. And here we have a network with 4 nodes, and we can make requests. So for example, I have the get balances here, where I made a request to my API to get the balance, like basic request. And so as you can see, I add all the data that I want. I have also a get block just under. And if I want, I can change the port here, and it will request to another node that will send me the same information because they are on the same network, so that you can launch a full network. I don't know if it's useful on your case. Most of you will just make like smart contracts, so it will not be useful, but it's something that I wanted to tell because it's really powerful and something that you can use if you find a use case. So just to stop it, you have to press enter on the terminal and it will clean up all your network. There is an error, but don't worry, everything is cleaned up. And yeah, that's basically the part on the sandbox node, that the one that you will use, and on the Docker ones. Do you have questions on any of both? If something is not clear, I can explain it again. We have a bit of time, so do not hesitate to ask question. Just to follow, I didn't see clearly the main.p did the job of, yes, it made everything. It made everything. It just like you have to edit the JSON. If you want, for example, to add more nodes, you edit the JSON and the main.p will take this JSON and create it. Yeah, as Damir said, it's really like for advanced coding. If you just want to make smart contract, you don't need to do this. Support looks super useful. Thanks. Yeah, you can make a lot of tests. I hope, like if you want to create like local network with, I don't know, your test your friends on one computer, you can with multiple Docker and stuff. I just checked the other question. They say was not enough. Yeah, yeah, one node is sufficient locally. Okay, if we don't have other question, I can just drink a bit, and we will. I will talk about smart contracts, so it will be like interesting for everyone. Yeah.
Maybe for the smart contracts, you can even before like showing the live coding session, like explain, like the languages we want to support and so on, because also like for some of the builders, sometimes they might think like everything is in Rust with Massa and so on. So yeah,
okay.
maybe
I will
to show that it's for everyone, so that everyone here is like actually like available to build on Massa. I mean, everyone can build on Massa.
So yeah, we want the smart contract to be really easy to write at first. Like there is no much barrier like we have in Ethereum with Solidity or in other language with Rust. So our smart contract compiles to WASM, if some of you are familiar with this term. But the thing that you need to know is that you can write your smart contract in a language that's called assembly script. Maybe you don't know it, but it's like a subset of TypeScript, I think, or or JavaScript or
TypeScript. So it's a subset of TypeScript, and the goal is that over the years it becomes feature equal to TypeScript. So it's basically TypeScript.
Yeah, because the syntax is like the same of the TypeScript, just there is some neat features that you don't have, but I don't think it will be useful for a smart contract. So yeah, we can say that it's TypeScript, even if it's not really true. And so for the website, you can work with everything you want. We have a cool and a big, I will just show how to use it after, but a big Webtra module in TypeScript and JavaScript and Node. It's compatible with browsers and Node. We had a hard time to do it, so yeah, it was complicated. And so as you can see, you can like connect to use it in your browser or in your Node application, and it will connect to the blockchain of Massa, and you will be able to like send smart contracts and operations. So there is everything in the README. I will send it to the chat. There is everything in the README, and so you can, for example, get blocks or send smart contract, send call smart contract. You can like, for example, call like you don't know your ERC20 token to ERC20 token to make transfers. You can make everything. So I just call through the README, and so this library is really powerful, and it will help you a lot on the front side. And on the back side, we have another one, and I will show you everything. So yeah, for the moment, the smart contract are written in assembly script which is like basically TypeScript, and the front end you can code on everything you want, but we have a library in TypeScript, JavaScript. Okay, so the meeting will end in 10 minutes. Nice. That's very good. Kesha, I don't know if you can change.
Yeah, no worries. I'm going to pay for adding time.
Okay, thank you. So I will go in an example. So we have like a repository in Massa. Also, we have a lot of repository, as you can see, with cool things like which is called Massa Examples. That will be very useful for you if you want, because we have a lot of example, not maybe a lot, but some example that cover most of the feature of the smart contracts. And so today I will show you the tic-tac-toe because it's visual, and you will see like the front end, and it will be more cooler than just a back smart contract. So yeah, we have a repository with the tic-tac-toe. So if you don't know the tic-tac-toe, it's like the game when you have to put 3 cross side by side or 3 O. It's 2-player game. So we have a part with smart contract, and we have a part with the code of the front end. So I will first of all explain like the smart contract parts, and after the front end one, and how we can interact with smart contract on the front end. I will like show you how the Webtra module works and a usage. So for the first part, I will show you like how we make smart contracts in Massa with the basic of the tic-tac-toe. So yeah, this smart contract is a smart contract of the tic-tac-toe, sorry. So to interact with Massa, you will use like the module Massa SCSTD, which provide a lot of functions. So you have functions to set data in the storage, because each address have access to a storage where you can set data with key values, such as you make for local storage on your browser, or a lot of storage systems that work with key values. And so you can set data and retrieve them in future call. We will see just after. You can also get address that have been called, like for example, the call style. You can get a lot of data interesting, like the time actual of your network. And you can also, something that we are interested in today because we will use this, you can generate events. So nice, thank you, Kesha. So what is this? Is like you can send an event to the network, and it will be able, and you will be able to retrieve it with your clients. So that's like debug message, so that you can see if your contract runs well. So the smart contract is basically 1, 2, 3 function. Yeah, 3 function. Like the first one is initialization. So as you can see, we set up some data in the storage because we will be able to fetch it later with our calls to the smart contract. And so here it's like the logic of the tic-tac-toe. It's not proper to Massa. Is basically checking if everyone has like here's a function that checks if someone has win, and this function, like I'm highlighting it, is a function that is called to play a turn in the game. So when you play, you will have some arguments that will be passed to the play functions, and these arguments are passed by your front end, and we will see just after how. And in these arguments, you will have an index, so where to place the cross or the hoe. And depends on where it plays, it checks if it's possible, like if it's not out of the bounds of the game, and check if someone has win. So this is the core of the smart contract. In order to deploy it to the network, you will have to use like a builder smart contract that will include your existing smart contract, so the smart contract you just coded before, and we'll use the function create SC, which is the function that we provide, and we'll set up your smart contract on an address on the network, and you can like generate events with the address so that you can fetch it and use it later. it's a lot of information, but I will make like the practical. I will launch it and you will understand more clear. So as we saw just before, if we want to test our smart contract, we set up a sandbox node. So it was the first part of the call. So I have my sandbox node on the right. I will make it a bit minimized because the information on it are not useful for us right now. Even I can just remove this from the screen. So I have my node on the back end. And what is WASM comparison compared to TS where we write? Okay, so I will explain it right now. I forgot this part. Thank you. So yeah, as I just tell before, the smart contracts are built are in WASM, which is a compiled form. Like you write in assembly script and you compile and it creates WebAssembly. So to compile your smart contract from TS to WebAssembly, we have a tool which is Massa script, and you have an example here where you can say build smart contract, and you give the source file of your smart contract, and it will generate a WASM file. And this WASM file can be included in the builder, need to be included in the builder smart contract right there. And after you have to build this builder smart contract also with the same command. So with Massa script build essay, and there you give the source to your builder smart contract. So src deploy.ts. And so here you have the second smart contract, and this smart contract use the compiled version of the first one. I don't know if it's clearer now. I forgot to just tell this part. Okay, nice. And here you can see that we also have a command to build another smart contract, which is the smart contract to play. But I don't think we will use it in this call, because we will play directly with the interface of web. So that's it. Does that mean that smart contract can be deployed programmatically on chain? Since to deploy it, you need to write another smart contract. Yeah. Yeah. Just you need to store the bytecode of the smart contract on chain, so it will take a lot of space in your storage. And in the world of Massa, we have like 1 terabyte of storage maximum for the whole network. So if you take a lot of storage, maybe it will you will have some drawbacks. It will not be free. So yeah, but you can totally make it. Maybe Damien, you wanted to say something.
Yeah, what's cool with this thing where smart contracts are able to deploy other smart contracts is that you can create a smart contract that arbitrarily deploys the whole infrastructure atomically, if you wish. There's been some attacks on some cases in Ethereum where people were deploying some smart contracts, and while they were being deployed, the infrastructure was not complete yet. Some people attacked them. Here, it allows you to have something like Docker Compose on chain atomically with arbitrary complexity. That's really nice.
Yeah, we just deploy one smart contract, but you can imagine deploy like a full application with multiple smart contracts. And yeah, so someone is asking to show the package revision. So yeah, you can see that we use the Massa SCS dependency. So it's the package where it provides you a lot of useful functions for the storage, etc. And so we update it a lot, because like you can see, we are not updated here because we are in testnet and we make a lot of changes. So be careful with the updates. CS, deploying CS for bomb proof. Damir? If you are still there.
Yeah, sorry.
Okay.
Yeah, sure. Basically, fork bombs, for those who don't know, is basically you would create a smart contract that's going to deploy two smart contracts and call them and copy itself, and again run itself twice and copy itself, run itself twice exponentially. But in our case, it doesn't really hurt because it's always limited by the max gas, the gas price, and the gas expenses that have been set up in the initial call. So there's no problem with that.
Yeah, if you are rich, you can set up more smart contract, but yeah, you are always limited by the amount of token you have. So Yeah, so I will continue if nobody have other questions on like the coding part. I will like make the deploy of the smart contract on the network, on my local network.
I think there's a question about the package.json. He wants to see the
Yeah,
package.json.
Yeah, just saw it right there. There is like the Massa CSTD, and I just explained that you have to be careful with the updates because we make a lot of changes, and because we're in testnet and we don't always follow the same version. We have to work on that. So yeah, be careful with the updates. But everything is well documented on the package. You have documentation for each function, for the parameter and the returns. And if something is not clear, you have the Discord channel to report to us, and we will improve the documentation. So yeah, I will deploy the smart contract on the network. So I have my account, as I just showed before, that I have some tokens, so I will be able to play a bit with that. So we have multiple commands on the client. The one that interests us is send smart contract, that will be able to send our smart contract to the network. So we can see that there is some parameters, so the sender address, which will be my address, the path to the bytecode. So the bytecode is the .wasm that I have compiled. So I will okay, it's in Massa Examples, games, tic-tac-toe, smart contract, build, and I have the deploy.wasm because it's this smart contract that will deploy the other. As you can see, I have the multiple wasm, but I want to launch the deploy one. And after we have to give the max gas, the gas price, the cons, and the fee. So I will add a lot of gas because I have a lot of money on this account, and I will set the other ones to little values. Okay. So I have an operation ID. So my operation has been sent to the network, and I can use the get operation command to see this state. So for the moment, it's still in pool. So we have to wait a bit, I think. The other command that will interest us is get filtered SC output events. So this command, you will be able to get all the generates events from all the smart contract of the network. You can add like filters on it, but as I am alone on my own network, I don't need to make filters because I have only my events. That's one of the benefits of running your own network. So I will be able to get all the event that has happened to the network. And as you can see, an event happened. So I can see that my operation is now on a block ID, which is final. And the smart contract has been created. Why it shows created tic-tac-toe smart contract at? Because you can see it's like the same print I have put in my code here. So it's the right smart contract that has been deployed, and we have his addresses right there. What's the cost of the storage in Massa blockchain as we process need gas? The storage need gas, if yes, what it will be? I'm curious to know how cheap, expensive it is. It's still we are still working on it. We don't have like a decision that we settle on. We have multiple possibilities and multiple ways to work on that.
Okay, the one way we are thinking to explore is that basically there's the simplest way is to say that since we have a maximum of 1 terabyte, we can say something very simple, which is if you put if there are, for example, if there's a supply of 1 million coins, for example, if that's the total supply, then we can say that the cost of a byte of storage is proportional, which means that if you put all 1 million, the whole supply of all Massas at, if you lock all of that to have some storage, you will get the 1 terabyte, the full terabyte. So it's a natural limitation directly with respect to the total supply of coins. And since the supply is meant to increase with monetary mass inflation, so the storage space will also increase.
I hope it answers your question.
So yeah, basically a constant price per byte in terms of coins. That's the idea.
Thank you, Demir. So yeah, the smart contract is deployed, and then we will be able to play with it with our front end. So we can see our front end here. So basically, it's a little React project. So you can see that I'm using the Massa Webtra package, which give me some cool interfaces to call the API without making raw calls like like a whole person. And so we have a bit of code to draw the game board. And the code that is interesting here, it's this one, because with the Massa Webtra library, you can, free library, sorry, my French gets me. So with the Massa Webtra library, you can call smart contracts, and it's like the same command as you have in the client, which is there, called smart contract. And you can pass the fee, the maximum gas, the price, coins, the address. So it will be the address of our tic-tac-toe, and the function that you want to call. So here we want to call play, and the parameter you want to give her. So when this function will be triggered, it will call the play function of our smart contract that is right there, and it will play on our smart contract. And there is like a generate event, so we will be able to see it on our node if it works well. So I will not go through the code of the front end except for the interaction with Massa, because it's only designs. And but I will launch it, and so you will be able to see me playing tic-tac-toe. So to launch it, I just run start like a basic React project. And so here we have also some information about the node that we added in the HTML file to debug or to see. So I can see that I'm running on my sandbox network with this node ID, which is my node ID that I use for my sandbox network. And so I can play on the game. So if I click on this up left case, it will add a cross, because the next player is a cross. So we need to wait a bit, and it should appear if it works well. Please appear. It will be cringe moment. Okay. Maybe if I reload. That's a cringe moment. Yeah, there is not much. So we can check in our generate event if something happens. Nothing happens. Okay.
Have you checked that your web page is sending data to the right smart contract address since you just generated it?
Demir is smart. Yes, so as you can see here, the smart contract has been deployed to this address. And so, as I mentioned just before, you have to specify the smart contract address right there on which smart contract you want to play in. And I haven't modified it with my new address, so I will do it right now. Up. So yeah, that's now the right address, and it should work well. Let's try again. It takes a bit of time, but not that much as we had just before. And it should appear, please. Not 2 times. Maybe a reload. Oh, it appears. Okay, so it just takes a bit of time, but you can play. So it's not like real time, because we have a bit of delay in Massa. But I wanted to show a game because it's more visual, but it's not the best use case. So as you can see, I'm putting like some cross, and we don't have output events because the smart contract do not emit once if we don't win. So I will try to win with myself, just so that we can see the generate events that will be right. Please work. Okay. And I'm the master of tic-tac-toe right now. The master. I am not. Okay, I'm the master. We can see that I'm the winner, and I win a tic-tac-toe, and we can see here the output event. So player X has won round, and after we can just press this button to reset the game. And so as you can see in the front end, it will call the function initialize. So the reset call the function initialize of the smart contract, and the play call the function play. And so you can interact with your smart contract like this with this super module. And if you don't code in TypeScript, JavaScript, you have to make like raw API calls, but it's possible. Just it's a bit more complicated. And yeah, that's basically it for the interaction. Do you have any question on this part? Was it clear? If you didn't understand something, do not hesitate. We are close to the end, so we have time. All clear. Nice. Cool. So you can find all the resources on Massa. All the repositories are in public in the Massa organization. So okay, nice. A lot of reaction. Thank you, guys. So yeah, you have web client is a TypeScript wrapper to call the Massa API. Yes, but not only to call the Massa API. It makes a bit more than that. It manages like a wallet. You have like helper functions to format your output. Like it just don't make raw calls. It helps you a bit more. It gives you more easier way to make the calls. So we can imagine if your community writes something. Yes, totally. We can imagine it right now if you want. You can do it. You can also contribute to either the simulator or this repository. If you think that something is missing, like it's too complicated, I don't know, to set up a new account, that you have a better way to do it, do not hesitate to contribute. We are always up to new contribution. Thank you. You showed me that I know nothing, a lot of work to do. Yeah, so there is a documentation on this also in Massa Reader Docs. So everything I've shown just right now is documented here with the example of the tic-tac-toe also. So if you follow this after the call, you will be able to make everything that I've just made right now. And if you have any question when you are deploying your first smart contract, do not hesitate to ask. We want everyone to be able to at least run and write some easy smart contracts. And if everyone can do this, we are more than happy. And our goal is to make the process as much easy as possible. I know that it's not very easy for now, but we are working on to make the things easier, like with this module. Can I undeploy my smart contract? No, you can. Yes, you can rewrite the bytecode. Like the smart contract is in the blockchain. You have the bytecode on one address, and you can rewrite on it, but you have to have the right permission. I don't know if Damir, maybe you have a clear answer.
Yeah. Okay, so basically, there's a question of permission. Of course, you don't expect a deployed smart contract to be erasable by anyone. It would be a security failure. So you need some kind of access rights. So what we have done in Massa is that basically the caller has access rights on itself. So if you deploy a smart contract on your own address, and instead of creating a new smart contract, you can also do that, by the way. And then you have full access, because you have your private key. You have full access to delete, change anything in a smart contract whenever you want, because it's stored on your own address. On the other hand, if you create an address, you have full write access over it until the end of the execution session. So in the same run, in the same transaction, once you have created the smart contract, you can have unlimited write, delete, everything access to it. That's used so that you can initialize it in the same run. But after this run is finished, you lose control over it. So if you want to keep some form of control over the smart contract, you can decide to put some kind of backdoor inside of it that's going to check whether the color is in an authorized list. And if it's the case, it can delete, it can add, it can change stuff on itself. But technically, nobody has direct access anymore, only through these kind of backdoor functions. The goal is that once you have deployed smart contracts, you can also guarantee that it cannot be changed by anyone, that you have full immutability.
Yeah, and just to give an example, Damir just said that you can deploy your smart contract directly on your address. So instead of making like create SC call, you can change it by doing a set bytecode. And it's a function that is provided by Massa SCSTD, and it will write the bytecode of the smart contract directly on your address, so that you have the full access if you want to delete, etc. But the smart contract is on your address, and everything else can be over. If there is another smart contract on it, it will be overwrite. So that's a possibility also. If I will try to make an error word and if it get anyways. Yes. If you make like a simple hello world smart contract instead of a whole tic-tac-toe, and you just generate event with a hello world, you will be able to see here with the get filtered SC output. If is it possible, could you show how the data of this round of games stored in the blockchain? Yeah, it's possible. I can make it easily. So I will reuse the script of the Python, and here I can get the addresses. So I will put my ports of my API. I think it's this one. And let me just check. I will make it bigger after. Okay. So yeah, it's this one. So I make it bigger for everyone to see. So yes, you can get your data from your API on your node. Why I can't just go to my repository? Okay, so for example, here I made a simple call to get the address of my node of my address of smart contracts, but did they put the right one? It's yeah, it's this one. So yeah, you can see that here we have the data store, which is the store with all the data, and you can see that one key is storing only 79. Another key storing a bit more. I think this key will be the board, the game board. But yeah, you can clearly decode. And what is this key? It's like the key that you pass in set data. So the key that you pass in set data right there, set data here. It's current player, but encoded in I don't remember, maybe SHA-256.
It's Blake 3 now.
It's encoded with Blake 3. So yeah, you can have your data here, and if you encode with Blake 3 this string, you will have the same hash here, and so you can check your values on your data store.
Just to clarify one little thing that's going to answer to some of the questions at the same time. It's basically we have this storage system that allows you to store things, and the way it's stored is that for every address it stores the balance of the address, it stores the bytecode, the executable bytecode associated to the address, and it has also this arbitrary data store, which is a key value store basically. And what's interesting with this is that these addresses can be anything. It can be your address, so you can put smart contract data in your own address, or it can be a newly created purely smart contract address that doesn't have any private key associated to it. In both cases, they are stored at the same place in the same way, and both have the same functionality. So you can use your own address as a smart contract address if you want. That's something powerful about Massa.
How do you handle version info on deployed smart contracts? So as Damien explained, as you can rewrite them, we can't rewrite them if you don't have access to it. But if you deploy the smart contract on your own address, and so you can rewrite it as you want, you have to handle the version on your side. We don't have like a standard way to do it because we think that the best way to deploy a smart contract is to deploy to an address that don't have private key, so that the users know that nobody can play with the smart contract and like make an update without telling anyone and get the data of everybody.
Just make a quick precision about versioning. There are multiple ways of doing it if you want. One way is to host the smart contracts and its data on your own address, which means that you have full access thanks to your private key. Another way is to deploy a smart contract that can be updated by itself. So there's a backdoor inside of it that allows itself to rewrite its own bytecode, for example. There's also a third option, which is to make the smart contracts immutable, but have some kind of domain name server, like something equivalent to Ethereum name system, where you register domain name pointing towards your smart contract address. And when you want to update it, you just deploy a new smart contract and you make this domain name point towards the new one. These are the ways you can update things.
Yeah, I don't understand the part about, but Damien just explained again. If you still don't understand, tell me and I can explain it again. Just a question, since the transactions are forgotten, there is a plan to create snapshots or dedicated archive nodes for tax purpose, for example. And maybe Damien, you have more answer on that.
Okay, yeah, that's more on my side. So yes, the blocks are forgotten because our system goes very fast. 2 blocks of 1 megabyte per second. So 2 megabytes of data per second, it goes really, really fast. It can grow really quickly. So we need to forget all blocks. That being said, so the goal is that people are able to host nodes at home, so they don't need a lot of storage. I mean, they need a 1 terabyte hard drive and that's it. So they will forget everything. On the other hand, nothing prevents people from also deploying nodes with higher storage capabilities and store more, like an archival node. In the case of Massa Labs, we are going to have some of those. We are going to have these archival nodes, and you'll be able to access them through an explorer that we're going to make. So no worries about that.
Is it possible to send Masscoin from the smart contract to another address? Yes, in the Massa SCSTD, like the standard library we provide where you have generate event and set data, etc. You also have a function to transfer coins from one address to another. So from the address of your smart contract to another, and also from an address where you have write access to another. Just you have to be careful that your smart contract address have coins, because otherwise it will not success. But yeah, if you have, you can send token through the smart contract. I think we made all the questions. Everyone else has any question? Or someone want to come for the last minute? I will like wait 2 minutes if someone wants some time to write a big question. Otherwise, thank you everyone for coming. It was very cool. I hope you know how to. I hope now you know how to set up your environment to develop and to make little smart contracts to start, and maybe build bigger in the future. And don't hesitate if you have any question. I'm quite active on Discord, so yeah, do not hesitate to ask any question. I will prefer you to ask more questions and understand faster than just struggling and be I don't know how to say it, but to not be happy with Massa. My vocabulary in English is like a 2 years old kid. Maybe, is there any Massa coding in Rust session planning? Oh, like a live coding where we make features in Massa. Maybe I wanted to do some on personal side, but I don't know if we will make with the company. Maybe something we can think about.
Well, if you want to stream some of your coding sessions with Massa Code, you can do that. There's no problem. There's also the opportunity for any of you to join us as to participate in the development of Massa. So by contributing to the source code, we can help with that. And we also, in terms of Rust, I want to mention that we are also planning in the medium term to support the Rust programming language for smart contracts as well. So here we go.
Yeah. Okay, so thank you everyone for your kind messages. Keisha, do you want to say any last word if you're still there? I don't have the participant list. Oh, see, I can have it. Those Massa Labs still there. Yeah. They want to say something, or you know, there will be more.
Sorry. I didn't have my headphones anymore. It's my fault because we received actually a Massa investor at the same moment. So I was like showing him around. So I apologize. But yeah, first thing, like super happy for everyone like to be there. I hope you had a good time. Give us your feedback, you know, like maybe it was a lot of information. Tell us what we can do better. Tell us if you would like to attend more of them. So really like on specific topics as well. I'm going to upload as well the recording and just like looking forward to build things with you, all of you guys, I mean, together. As you know, Aurélien, Damir and Thomas are like also like much more like available than on other channels, but on the builders channels, they're like really super available. And we have many other cool things to come. As you know, we like to do things differently. I think soon you will have probably, so if you like this meetup, we'll do probably a meetup regarding our clients, so heavy client that Gregory is developing. And also Joseph, who is on this call, has developed something very cool also related on this kind of part. Just amazing work what you do, Joseph. Just wanted also, and all of you really, I mean, thanks for what you are doing. And looking forward, and I hope also, I know some of you had like discussions and questions regarding pushing their own website, for example, on the Web3. So I hope it's going to be helpful for you to be able to push their website and to know how to do more. Maybe next time we can do a very short session just to how to deploy your website on Massa and to claim a DNS. I think it could be a cool idea.
Yeah. So thank you, everybody, and have a great evening, day, night, depending on where you are on the planet. And bye, I guess.
Thank you. Thank you.
Bye.
Bye-bye, everyone.